Many of us have probably thought about this at least once. Just how big is our universe, and where does it end? Could we ever go to the end of the universe and see what's there? We're all so curious about these questions. Unfortunately, no matter how much our technology advances, it will be impossible for humans to observe or reach the end of the universe. Why can't we go there or see it? Let's explore the reasons. Starting from the Big Bang, everything in the universe began. Time started to pass, space emerged, and galaxies, stars, and atoms were created. The fascinating fact is that before the Big Bang, the universe was condensed to a size even smaller than an electron, and when the Big Bang began, the universe expanded while simultaneously being subjected to the half-gravity of the universe, causing it to expand. However, the speed of this expansion is beyond imagination. At a point in time that passed 1/1,000,000th of a second after the Big Bang, the expansion rate of the universe was faster than the speed of light. According to Einstein's theory of relativity, nothing can move faster than light in the world. So, how can the universe expand faster than light? Is Einstein's theory of relativity wrong, or is the Big Bang theory strange? It's somewhat ironic, but both the theory of relativity and the universe expanding faster than light are correct. Why? In the case of the expanding universe, what is moving is not a specific substance, but space itself. Therefore, even if space itself expands faster than the speed of light, it does not violate the theory of relativity. It's really amazing. Let's use a balloon as an easy example. Here's a balloon, which represents the space of the universe. Let's draw a galaxy on the balloon and then inflate it. As the balloon expands, the distance between galaxies gradually increases. At first glance, it may seem like the galaxies are moving, but in fact, the space expanding causes the galaxies to move away from each other. Let's go back to the Big Bang story. Only a fraction of a second after the Big Bang, the universe expanded to an enormous scale of 10 to the power of 50. The universe is still expanding, and the expansion rate is increasing with time. Is the expansion of the universe continuing and accelerating? If so, what will happen to the universe in the future? If there is no event that can significantly halt the expansion of the universe, in about 150 billion years from now, the stars visible in the night sky will decrease significantly compared to what we see today. According to research by scientists, 99.9% of galaxies around the Milky Way will move beyond the observable range. In other words, the stars will no longer be visible. The galaxies are moving away from each other at incredibly fast speeds, even faster than the speed of light, which means that the light from these galaxies will no longer reach Earth. Of course, galaxies don't actually disappear just because they are moving away from us. However, since the light emitted from those galaxies cannot reach Earth, from our human perspective, it will feel like the existence of those galaxies themselves are disappearing. Currently, there are approximately 100 billion observable galaxies. However, after 15 billion years from now, this number will decrease to only a few thousand. What will happen as time goes on? We will only be able to observe a mere 36 galaxies, and all other galaxies and stars will seem to disappear completely. After a very long time, the night sky filled with twinkling stars and galaxies will become completely dark. If there were astronomers on Earth even after several hundred billion years from now, they would probably think that the universe is not expanding because galaxies that are grouped together locally do not move away from each other. They would believe that the universe consists of only 36 galaxies and remains in a static state. But why don't these 36 galaxies disappear from view? It is because the gravitational force between galaxies that are clustered together locally is strong enough to overcome the expansion of the universe, keeping them visible. The space of the universe, born from the Big Bang, is expanding at a speed much faster than the speed of light, and the expansion rate is increasing. As the distance between galaxies increases, the speed at which they move away from each other becomes faster. With this fact firmly in mind, we will take a spaceship that can travel at 99.9% of the speed of light and go to the end of the universe. However, we can never reach the end of the universe because the rate at which space expands is faster than the spaceship traveling at the speed of light. This is a kind of physical law that applies to the natural world, so there is no way to ignore it. Therefore, we cannot even observe the light approaching from the end of the universe, and even if we move at the speed of light, we will never reach the end of the universe. Because of this physical limitation, the scientific community has made a sphere based on the radius of the Earth. This range is called the observable universe. Now, one question arises: how big is the observable universe? Scientists used the WMAP satellite to capture the appearance of the universe 380,000 years after the universe was created in the Big Bang, and humans found that the universe is approximately 13.8 billion years old based on this. Now, since we confirmed 380,000 years after the Big Bang in the age of the universe, does the radius of the observable universe amount to 13.8 billion years? Intuitively, this may be correct, but we have overlooked one important fact. The light that is reaching the Earth now is the light from 13.8 billion years ago. However, the universe has been expanding since its birth 13.8 billion years ago. Therefore, the origin of the light has been pushed much farther away, up to 465 billion light-years. Thus, the size of the observable universe is a spherical shape with a radius of about 465 billion light-years from the center of the Earth. Now, here's the last question. If the observable universe is determined based on the Earth, what is beyond the observable universe? Can we observe or visit that universe? Unfortunately, since we as humans can never defy the laws of nature, we can neither visit the end of the universe nor know what is beyond it. Therefore, scientists lament that they can only imagine what is beyond the observable universe and how much further the universe stretches. Some scientists say that if the size of the observable universe is compared to the size of an atom, the size of the entire universe will be as large as the observable universe, or that if the observable universe is the limit of human perception, then that is the end of the universe. No matter how hard humans try, they cannot reach the end of the universe. However, it's interesting to note that the universe may not be as big as we think, so we might be able to reach the end soon. Nonetheless, since it is an area that humans can never truly understand, it allows for a lot of creative imagination. Perhaps, as science and technology advance, we may someday be able to determine where the end of the universe is. If there is an end to the universe, what do you think might be there?